The material sent to us to be recycled or salvaged, it's fairly difficult, and I'll just show you some reasons why. If you look at this piece, this has already been pressed together, and it's very condensed, and this is easy to get through. It cuts real nice, and it's pretty simple. This part of it, if you see how it expands, it gets very thready and fibrous. Very difficult. It's going to require an extra strong machine, and it slows the whole process down, that type of material. So that's the first thing. The second thing is it's all kind of hooked together in like you had on a roller, and you're just stamping them out. And it makes it even more difficult because the size of the machine has to go up so greatly to do it. But what I'm going to do is I'm going to cut some of this stuff and just kind of give examples of what happens to it. It actually doesn't size reduce, actually negative size reduces. What most people do with this material is they'll bale it and kind of compress it that way. But when you put it through a machine, it's going to go the opposite way. It's going to get very fibrous, have a lot of air in it, and its density is going to be less. So you actually end up with more material rather than less material. We're going to run your test on a GSL 300-400. This is a 10 horsepower unit. With material like yours, if we're going to do a large volume, we have to go up to a much larger machine, 150, 180 horsepower if I do some significant volume just to get through it. What I'm going to do is just run these tests, not to prove out the machine, but to just provide an example of what you're going to get back. And if you like what you get back, then we can talk about the size of the machine. Folks who do material like this, we have customers who actually do material like this, and they use this machine as, I'll call it beside the press, but it's not really beside the press, it's beside the workstation. So when the employees work in and they're stamping it out and making the part, they'll take the skeletons, just drop it in here, grind it up, and we blow it to the back room where we recycle it. And your process seems more of an inline process, which will require a larger machine for the stamping process. But we're going to run this and send the results, and we can go to the next step. What Paul's going to do is drop in some of the thinner pieces just so we give a good example of it. Ready? We're not going to have to, I'm just going to turn it off. And then I'm going to open it up and kind of show you what's going on. What's happening to the material, it's just getting kind of dragged around and fluffing up. And you can hear the motor's already starting to bog down on it because it's not getting through. And what we're using here is a 12mm screen. And what we do for other folks is we have a much larger screen, like a 30mm screen, to break it down. And then when it goes into the recycling process, right before it's pelletized, we break it down even more. But if you look what's happening, the stuff is just bouncing apart, starting to heat up. And what we did is we installed a brand new set of knives in the machine for this test, just so we gave it the best chance possible. But what it's doing is it's just chopping it up. It's not going to go through the screen this way, because as you pull on it, it actually, the material expands. It makes it even more difficult. Here's a good example. It makes it more difficult for it to go through the screen for it. So if I kept adding material to this, the only thing I do is jam up the machine. It'll amp out and just shut down on us. But it does have brand new knives in it, brand new bed knife in it, and it's cutting it, but it's actually, as it cuts it, it pulls it, it makes it larger, so it's not even getting through a 12mm screen for your test.